Okay, chapter 12 is on logarithms, and logarithms were invented because people needed something to get rid of exponents. So for instance, let's say that we know that 2 to the x is equal to 5, and we want to know what x is. And okay, we can guess. Let's see, if x was 2, 2 squared is 4, so it's bigger than 2, but less than 3, because 2 to the third power is 2 times 2 times 2, which is 8, which is less than that. So we could guess maybe it's x is 2.1 or something like that. But guessing is not the way you want to go about it, so people invented logarithms. So logarithms are the inverse function of exponents. So what we need is a function that we can take the -1 of both sides, and then that would get rid of the 2, and then we just have x is equal to some function of 5 that you can plug into your calculator or work it out, and you can figure out what x is. So logarithms get rid of the exponent of the base. So, and I looked up once why they called it a logarithm, and it didn't make much sense, and I forgot. But oh well, we're stuck with that word. So instead of calling it f-1, they had to give it a name. So since it's called logarithms, they call it log. So, and then there's different bases. Since here we go back to our example, 2 to the x is equal to 5. This is a base of 2. So if we take the log base 2 of both sides, log base 2 of 2 to the x equals log base 2 of 5. Log base 2 cancels out the 2, and we're just left with x, because that's what inverse functions do. So x is equal to log base 2 of 5. And you plug that into your calculator and you get the answer. However, unless you have a really fancy calculator, there is no log base 2. There are only two types of logs in most calculators. There's regular old log, which is typically base 10. If it doesn't say, it's base 10 because that's commonly used. And then there's the natural log, so ln, kind of natural log backwards. And that's base e, where e is this magical number that we'll talk about later. So if you want to know the log base 2 of 5, like the first problems in chapter 12 or something like that, how do you do that if your calculator doesn't have a log base 2 button? And so, so here's how you figure that out. So let's say we have log base b, they typically call the base b, because it kind of makes sense, b for base, of x is equal to something. Okay, we want to know what that x is. So, actually, wait, that's a separate example. Well, we'll do this example first. So, what you do, since log and exponents are inverse functions, we raise both sides to the b power, or raise b to both sides, I guess is the better way to say that. So b to all this stuff, and b to the a power. B and log base b cancel, because that's what inverse functions do. So on this side we're left with x, and the other side we're left with b to the a. So if we have an equation like log base b of x is equal to a, and we want to know what x is, you raise both sides to the b, to the base of b, and then x is equal to whatever the base is to the a power. And you can plug that into calculators. Like let's say the base was 2, and that number over here was 5, it'd be 2 to the 5th, and you can plug that into a calculator and get 2 to the 5th, and that's pretty easy. But the other way around, which is what I meant to do here, is what if we have something like log log base 2 of, let's say our example over here, of 5 is equal to what? So we want to know what that is equal to, because we don't have a log base 2 in our calculator, and that's what I've been trying to say. So it turns out that we can use our other functions to get that. So if we raise both sides to the 2 power to get rid of the log, okay, so let's say log base 2 is equal to, instead of question mark, let's call that x. We raise it to the 2 to those powers, 2 to the x. That cancels that out. We have 5 is equal to 2 to the x. Now we can take any log we want of both sides. Let's take just regular old base 10 log of both sides. So then we get log base 5 is equal to log of 2 to the x. And, okay, now you can see it. And, because right, log of 5 on this side, log of 2 to the x that side. Now, for a property of logarithms is log of something to a power. Like here we have log of 2 to the power. That's the same thing as x. You put the exponent in front, put the power in front, so that's x log 2. Or finally, now we can write this as what we're looking for was in the very beginning was x. What is the log base 2 of 5? So x is equal to the log of 5 divided by the log of 2. And we have a log button in our calculator. We could use a log base 10 or ln. It doesn't matter. Either one works as long as they're the same. So this would be log base 10 because you have that button in our calculator, and it's the exact same thing. We could use the ln of 5 divided by the ln of 2. Okay, so what you really need to know after all that was that if we have something like log base b of some number a, and we want to know what that is, a could be 6 and base could be 5 or whatever, the way you figure that out is use either button like ln, and it's always ln of the number that you want to take the log of, a in this case, divided by the natural log of the base. Or again, you could use log base 10 as long as they're the same. So that's the way you do it. If you have a log of some base you don't know, you just take a log you do know on your calculator and then divide it by the log of the base. Okay, so that is one formula that you're going to use a lot to figure out stuff. And okay, the other major formulas that you need a lot in this chapter, which I alluded to one of them already, is that if you have the log of some number a to a power, that's just equal to b times the log of a. And again, it works with natural log or any base. This works with, not just base 10, it works with any log. So I'm not writing 10 there, it could be any kind of thing. So that's one of our formulas. Then the other couple of ones that you're going to use a lot is like log of two numbers multiplied together, like log of ab. I probably should put parentheses around these. Log of a times b is the same thing as log of a plus log of b. And the third one is log of a over b is the same thing as log of a minus the log of b. Those are going to come up a whole lot. One that you have to be really careful of is if you have the log of a plus b or a minus b, plus or minus b, then you can't do anything. That's just the way it is. There's no relation we can simplify that with. That's just equal to the log of a plus or minus b, and you're going to have to figure out something else to solve the problem because there's no way to break that apart. What you can break apart is if they're multiplied or you have a power. Okay, so those are the basic logarithm relations that we're going to use a whole lot to solve problems. Let's just do a few examples here. So let's say that we want to know what the log base 5 of 10 is. Okay, so what this is asking, and this is the whole thing, is they're asking what exponent do we raise 5 to get 10? Okay, so the words are what exponent, what power, what exponent do we raise 5 to get 10? Okay, so again we can guess. Raise 5 to the 1 power, it's 5. That's not big enough. 5 to the 2 power is 25. That's too big. So probably it's 1.1 or something like that. So then how do we know exactly? Well, we use the rule we just said. Okay, we don't know what log base 5 is. It's not in our calculator. But we know this is the same thing as, I'll write it down here. This is the same thing as, let's use log base 10, which is in our calculator, of 10 divided by log base 10 of 5. And that I can put in my calculator. And if I do that, okay, so log base 10 of 10 Oh, that's a log base 10 of 10. That means what power do I raise 10 to get 10? Well, that's obviously the first power, so that's 1. And then log base 10 of 5, what power do I raise 10 to get 5? It's going to be less than 1 because 10 to the 1 is 5, so it's going to be less than 1. So I know that, and I plug that in, and I get 0.69897, 0.69897, and I divide those two, and I get 1.43. Good enough. Okay, so if you don't have the log button in your calculator, you're okay, because you can just use this relationship, that the log of the number divided by the log of the base. And again, the whole idea of logarithms, they're the inverse function of exponents, and they ask you, what exponent do we raise 5 to get 10? Okay, one more problem. Let's say 4 to the x power is equal to 30. Okay, we want to know what power that is. What's x? Well, again, we can guess. If x is 2, it'd be 16, so it's bigger than 2. X is 3, 4 times 4 is 16, is 64, so it's less than 3, so maybe 2.5 or something. But how do we know for sure? And so what we want to do is take the log base 4 of both sides, but we don't have a log base 4 in our calculator to get rid of the 4. So instead what you can do is just take, let's try the ln this time, let's take the natural log of both sides. Okay, natural log, that's natural log of 4 to the x equals natural log of 30. Natural log of 30 I can do in my calculator. Natural log of 4 to the x I can't exactly do, but we can use the relation we just learned that raise natural log of something to a power is the power in front. So that's x ln of 4 is equal to the natural log of 30. Or finally, divide both sides by ln of 4, x is equal to the natural log of 30 divided by the natural log of 4. And again, I can plug those in my calculator. And again, you don't have to use natural log, you could use log base 10 as long as it's the same one on both sides. So 30, what power do I raise e to? E is 2.71828, the base, natural log base, to get 30. That's what I'm doing here. That's calculator can do it for me. That's about 3.4. And then divide that by natural log of 4. So 4 natural is that's 1.386. So I divide those two, and I get about 2.45. So I was close, and I guess 2.5, about 2.45 or so. So that's the power we raise 4 to get 30. Okay, hopefully that helps. The first problems in Chapter 12 have to deal with that, and these are skills you just have to know to be able to solve these problems.